So continuing the discussion on fermentation, in this section I'm looking at a first-hand investigation which looks at mass changes during fermentation, and this is an experimental section. So in the school laboratory, this experiment can be done to show how fermentation occurs and how it can be measured and seen. So this is the apparatus that you will be using, where we have two conical flasks on the left and the right, and they're hooked up or linked by a tube up the top. Okay? Now the aim of this experiment is to conduct fermentation of glucose and to monitor the mass changes. And if you remember, glucose, when you add yeast, you get ethanol and carbon dioxide gas. And this is what this animation is showing us. So on the left, we start with a reaction mixture which will have glucose in it, which is the starting product for fermentation. And then if we add some yeast to this, what's going to happen is it will produce ethanol and carbon dioxide gas, as you can see here. So what's actually happening is the mass of the reactants in the reaction mixture will actually decrease as carbon dioxide gas is given off. And this carbon dioxide gas will then go through into this lime water, and its mass will actually increase. And if you can see here, what's actually happening is this solution is turning from clear to white. And that's because lime water is actually a concentrated solution of calcium hydroxide. So that's lime water, and the calcium hydroxide reacts with the carbon dioxide gas to form a precipitate, a white precipitate, which is calcium carbonate. So that's why in the lab you'll see that this solution will turn white. And then you can go and measure each day how that mass changes, and you can quantify how fermentation is actually working. So it's quite exciting to watch fermentation in little apparatus like this in your school laboratory. So let's talk about that. First of all, we have the reaction mixture, and it will contain 100 ml of 10% glucose solution. So there's our sugar that we need for fermentation. It'll also have 0.5 grams of salt, and this is to help the yeast out. So we have 3 grams of dried yeast. Of course, we need that as our biological catalyst for fermentation, and the salt helps the yeast out. And if you've ever baked bread or pizza dough or seen anyone do it, they'll always add salt to help the yeast along. So in the lime water, you'll have 150 ml of lime water, and as I said, it's concentrated calcium hydroxide, which means there's so much calcium hydroxide in there that it's almost coming out of solution into a precipitate, but not quite. So the method, what we do is we mix the components of the reaction vessel and we weigh it along with the stopper. Now we need stoppers because if you think that they're in that reaction mixture it's producing carbon dioxide gas, you don't want it to escape. So you do need to put that plug on very tightly. And in the lime water, we also weigh the lime water vessel along with the stopper and the delivery tube. And we do that before we start the reaction to see what they weigh at the very start. Now, I've mentioned already that lime water is calcium hydroxide solution. So, our method. First of all, we have to set up the apparatus so there's no gas leaks. And just remember back to that diagram, that's how we're setting up this apparatus. We need to make sure there's no gas leaks so the carbon dioxide doesn't escape. The hose from the reaction flask has to be connected to the top of the glass tube in the lime water sidearm flask. Okay, that's quite important. The glass tube must finally be immersed into the lime water. So that's so that the carbon dioxide can actually go through the water and react with that calcium hydroxide. Because if you just, say for example, this is our flask, if you just put the sidearm to here, for example, and you had this level of your lime water, as you can see, you'd get your carbon dioxide at the top, and it might react a little bit on the surface here of the lime water, but it wouldn't quite fully get in there. So you'd get results that weren't quite correct. So it's got to be fully immersed. Now, we separately weigh the reaction flask and the Limewater flask every day for 1 week. We then record and tabulate all of the changes of the mass of each vessel. And have a look at the physical change in the Limewater going from transparent to white colour. So every time you see it starting to get white, you can think that's calcium carbonate precipitating out, okay? And at the end, if you wanted to go on, right at the end of the experiment, you could filter this and get solid calcium carbonate for other uses in the lab. So I've mentioned that, and this is the equation for the precipitation. So you've got your calcium hydroxide, which is aqueous in the Limewater, and you get the carbon dioxide from the fermentation in the reaction vessel, and this goes to calcium carbonate solid, the white solid, and liquid water as your byproduct. So a few things to consider when doing this experiment. For it to be accurate, you need to maintain the temperature of the reaction mixture at 30 degrees Celsius throughout the fermentation. Now, this can be done using a water bath in your laboratory, or you could even make your own, but you have to keep it pretty constant, which is difficult in a school lab, but if you're lucky to have good equipment, then you can do that. Because this optimizes the rate of fermentation. If you'll remember to the previous lesson, fermentation is optimized. In industry, it's actually 37, but in school laboratories, 30 is a reasonable proximity to that. So you need to create a control reaction mixture without the yeast to ensure there are no changes in mass of the apparatus. And there probably more than likely won't be, but every experiment needs to have a control. So you definitely need to create that control. Now, for reliability, use the collected data from other groups who do the same experiment as you, either in your class or in your school, or maybe old results from last year. And take an average of the trends in the mass, because every experiment will be different. People will do things differently. They might accidentally weigh too much or too little. They might put in too much or too little. The temperature might not be right. There's so many variables that you're better off taking an average to get the results for the final for this experiment. So the results, what's going to happen is you're going to get loss of carbon dioxide from the fermentation flask, and this should result in a drop in mass. Because you're losing the carbon dioxide from the glucose, that will result in a drop in mass. And so on the other side then, you'll get an increase in mass in the Limewater flask, okay? Because it's absorbing the CO2 and it's precipitating calcium carbonate. So of course that precipitate is going to be heavier than CO2 gas, so therefore this flask, the second flask, will increase. And we've mentioned it that it's cloudy white. So now theoretically the mass decrease from the fermentation flask should equal the mass increase of the Limewater flask, but unfortunately in laboratories, and not only school laboratories but all laboratories, things go wrong, and the reason for this, especially in a school laboratory, is the fact that you're probably going to get air leakage from the system, to and from the system, and also the existing atmospheric carbon dioxide will be absorbed into the Limewater. So that will change the results as well, and it may distort expected mass changes. So if this was in a really clean laboratory and they wanted really perfect results, they'd actually do this experiment under an atmosphere that didn't have any carbon dioxide. Okay, so perhaps under nitrogen, something that wasn't reactive but also didn't contain carbon dioxide. So finally, to recap, this is our picture again of the apparatus that you'll be using. So you've got your reaction mixture on the left with your glucose and your yeast, and its mass will decrease because it's producing carbon dioxide, which will go into the Limewater, which is calcium hydroxide, and so its mass will increase. So that's the school lab fermentation experiment, and I'll look at some questions now. Question 6. What are some differences between industrial fermentation and the school laboratory fermentation? Okay, first of all, the presence of oxygen. The industrial fermentation vessels can seal out and exclude oxygen from the reaction. But in the school laboratory, there are uncontrollable leakages of oxygen into the fermentation flask. So there's nothing you can do about that. Also, the ethanol concentration. It's monitored in the industrial process and it's maintained below 15%. This is to prevent killing the yeast strains. So if you remember, even though they use alcohol-tolerant yeasts, they will also start to die after the ethanol content gets above 15%. And ethanol is removed from the fermentation vessel as it's formed in the industry. In the school laboratory, however, the ethanol concentration is not monitored, okay? They usually don't have the equipment, or there are other things that need to be done instead. And also ethanol purification. Ethanol from industrial fermentation is concentrated further by distillation and fractional distillation, okay, to increase the ethanol content. So up to 96% of ethanol purity can be produced. And if you remember, we can't get much higher than 96% because of the high hydrogen bonding between the water and the ethanol. And ethanol is not purified in the school laboratory for a number of reasons, one of which would be the equipment. Another is that people under 18 shouldn't really be near pure alcohol. And the lime water. No lime water is used in industrial fermentation, okay, there's no need for it. But it's used in the school laboratory to test the presence of carbon dioxide formed and to show you that the reaction's actually going forward. So to see that CO2 is formed from the fermentation process. So there's a few differences between industry and school, but you get the picture that you can see that fermentation is occurring. And our last question for this section is question 7. Explain the changes in the fermentation flask and lime water flask of a school laboratory fermentation experiment. So what do we see? We see that the mass of the fermentation flask will decrease as the CO2 produced in the reaction is passed off in a gaseous form. And it's then passed off into the lime water flask, okay? So the first thing we see is a mass change. And on the other hand, the mass of the lime water flask should increase because it's absorbing the incoming CO2 gas. Okay, so the clear lime water, hopefully you will see, is turning a milky white colour as calcium carbonate is formed with the absorption of that carbon dioxide. So that wraps up the experiment looking at fermentation by using masses and weighing the masses and also observing colour changes. You can tell that a reaction has occurred where glucose has turned into ethanol and carbon dioxide. The carbon dioxide has moved into the lime water, creating a precipitate that you can measure. So that's all for this section.